Good morning, Tehmina Khan is here in TKMaths Yr. In this video, we will see a question on integration tan inverse with partial fraction. This is a part of the syllabus of A-level mathematics, B3, and in Excel course as well. So let's see the question. This question is taken from March 23 variant 3.2. You can see in part 1, you have to express this algebraic fraction into partial fractions, and then later on you have to integrate it. So as we solve the question, it is not only the solution of the problem but also help you to recall the whole topic. So here I'm helping you to recall partial fraction. When we are generalizing it, we have 4 options here based on the denominator. So the one we have has quadratic expression and linear expression. Quadratic expression which cannot be further factorized. So if you see out of these 4 cases of partial fraction, it goes with this one. So I will generalize it like this. On the top of linear function, one constant, and on the top of quadratic function, it will be a linear function. So I have written it here just to save time. The whole question I'll solve, but few expression I have just written here. And after that, I will take LCM. So when you take LCM, denominator I'm not writing because it will be the same on both sides, and when you are solving you don't need that. So now after that I will expand the bracket and collect like terms together. The whole purpose is to have on the right hand side the coefficient of x square, coefficient of x, and constant term. So after that I will start comparing, because now it is in the same format as is on the left hand side. So comparing the coefficients. Achha, by the way, there are 2 methods to find out this value of A, B and C. One method is comparing the coefficient and other method is substituting the values of x. So I'm going with comparing the coefficient. It is your choice, whatever method you want to adopt here. So first of all, I'm comparing the coefficient of x square. So 5 is equals to A plus B. You can see here the coefficient is 5 and this side the coefficient is A plus B. Let's call it equation number 1. Then compare the coefficient of x power 1. This side I have 1 and the other side I have B plus 1. So you will get B plus C. So let's make B a subject from this equation and it will become 1 minus C, and I will substitute it in equation 1. After that I will compare constant term. You can do it later. I'm just doing it right now. It is your choice. So 5 is equals to A plus 1 minus C, and I'm making A a subject. So it will become 5 minus 1 plus C equals to A. So you got 4 plus C equals to A. Let's call it equation number 3. Changing the color to make it look little different. Now I'm comparing the coefficient of x naught, which is constant. This side I have 11 and this side 4A plus C. So 11 is equals to 4A plus C. So now let's call it equation 4 and we can solve equation 3 and 4 together. So I'm going to substitute this value of A here. So it will become 11 is equals to 4 times 4 plus C plus C. So this will help us to get the value of C. So C is equals to minus 1. Now after that you can substitute it in equation 3 to get the value of A. So let's see. Always give a reference of the equation you are using. Like I have written 3 implies. So this helps us to get the understanding which equation we are using. So here you get A is equals to 3. Now after that I have to find, now I have C, I have A, now B. So let's use equation 2 now. So it is B is equals to 1 minus C. So that will give me value of B 2. So now I have the value of ABC, which I will plug in this partial fraction, right? copy it down here. Give me a second. Okay. Okay, so in place of ABC, now I will substitute the values. So A is 3, B is 2, and C is -1. So now you have gotten your values here. Partial fraction part 1 is finished. Now part 2 is about integrating it. So now here I have written, let me take it up here. Okay. So now I'm going to integrate it. Here I will help you to recall another function of integration, which is f prime x fx. When this is the situation to integrate, it is equivalent to ln of f of x. So mostly in the partial fraction integration, this is applied. So if I look at the first function, right? So I can say, let me split it into parts so that it becomes easy. If I write it like this, okay, just keep it like this. So do you think if you differentiate 1 plus x, the denominator, the answer of the differentiation of 1 plus x is 1, which is present here. So this part will become ln 1 plus x. Limits I will apply after a while, right? So limits you can apply here. And this second part of the integral function, this one, now let's see what happens here. If I split it into two parts, 2x divided by 4 plus x square, and the last one is 1 over 4 plus x square. Now here you need to understand there is no method to recognize. Once you practice, you understand how to further solve it. So again, in this part, this is applicable. Why? If you differentiate 4 plus x square, your answer will be 2x. So it means this is fulfilling the situation. So integration of this will be ln 4 plus x square. Right? This is a perfect situation. So I can apply limit on this one as well. So what it will be? 0 to 2. Okay. Now this is the last one. Here it is tan inverse case. Now you need to recall this, right? Once you look at this situation in the denominator here, it helps you to recall immediately the integration of this form. Right? What is the integration of this? It will be in the formula list also for you. So this is equivalent to 1 over a tan inverse x over a. So if I compare with this, instead of 4, I can write here 2 square. Right? 4 is equivalent to 2 square. So it will match the perfectly with this. So it will become 1 over 2 tan inverse x over 2. Right? So now you can apply limit on this also. Write down limits properly everywhere. So you can do, you can apply the limits all together, or you can do it in parts, so it is all right. So let's do it as we have written here in parts only. So it will become upper limit is 3 ln 2 plus 1 is 3 minus, this is upper limit. I'm using different colors so that you do not get confused. 3 ln 1, because now I will put x0, right? So this one is done. Now the second part. So I will do upper limit to ln, when I will write here 2 is 4 and 4 is 8. So ln 8 minus lower limit ln 4, because now you will put it 0 you will put here. So 4 plus 0 is 4. Now we will do here the last part. Half I can keep outside the bracket, or it's okay, right? So now upper limit is tan inverse 2 over 2 minus lower limit is tan inverse of 0 when you put 0 in place of x. So that will be equivalent to 0. Right. So now I will just expand the bracket here and see the situation. Here I can write ln 3 power 3. Now why I am doing this? Because I know I have to prove that it is equals to ln 54 minus 1 over 8 pi. We know when we have to apply log of product rule and quotient rule, there should be no multiplier. So let me help you recall that also. If it is ln A and ln B, there is plus sign in between. It means it is ln A times B. And if it is ln A minus ln B, then it is ln A over B. A divided by B. And you see there is no multiplier. So that's why I want 1 here. So I'm applying power law. In power law, the multiplier goes as a power on the number. And we know ln 1 is 0, so this term will be 0. Now here it is ln 8 minus ln 4. And if I see here, minus half, now tan inverse 1. If you see, it is equals to pi by 4, right? So what I'm getting here is ln 27 times 8 divided by 4. What did I do here? If you see, this term is with ln, this term and this term. These 3 terms are here with ln. So when there is a plus sign, this number and this number will multiply. But when there is minus sign, this number will divide because of this rule. And half tan inverse 1 will be equals to pi by 4 because tan inverse 1 is pi by 4. So now if you see here, you will get here ln, let's use the calculator, 27 times 8 divided by 4 is 54. And this is pi by 8. So you can say proved. Right, this is what you have to prove here. So thank you very much for watching the video. Please press like and subscribe button and share it with your friends. I would appreciate if you can comment also. How did you find it? If you have any question, take care. Allah Hafiz.